So, assembler. Assembler has been developed to really show young people what engineering is. We start with, we use real engineering parts and real engineering processes, okay? So if I tip some of these out, I'll show you exactly what I mean. Now this is a kit. We use to identify parts. We identify what gears are, what drive shafts are, what chassis is, what bearings are, and what nuts and bolts are. These are all real engineering parts, okay? And from this, the diagram and information, students can quite quickly make one of these, which is a nice gear spinner, okay? So immediately, we've introduced parts. We've introduced metal bearings. We've introduced nuts and bolts and the processes involved in building. For instance, we are press fitting a bearing into a hole, and that is called an interference fit, which are used everywhere in engineering. Okay? So we've given the student a plan, they've built this, and suddenly they've got ownership. They feel like they've achieved, and they've learned some engineering concepts. Yeah? So what we can do with this very small, quick activity is move on to larger scale activity. Now, Assembler has been designed, and this is what sets it apart from all other kits. Assembler has been designed with one length of components. And these lengths of components can be cut using the cutters. So we're focusing on design. We're thinking about how things work. And what we want to do is we want to build from the same brief at the beginning of a session. We want every student to have something different at the end of the session. Because when you cut, you can cut to any length, of course. Yeah? So it's quite straightforward to cut the pieces, which means that you've got an unlimited number of design options. Okay? We can make things like this, which is a vegetable racer. This was built by a 11-year-old student. Okay? The brief was to design and build a car that could hold different sizes of vegetables, and when we run it down a ramp, we need to find how far it goes. The car that goes the furthest is the winner. So we're already talking about friction. We're talking about distance, velocity, and time relationships. We're talking about engineering processes of press-fitting bearings into holes. We're using the nuts and bolts. Yeah? And from the same brief, the whole class has different outcomes, different designs. So what we're doing is we're looking at this. We're looking at this process here, which is researching, we're prototyping, we're testing, we're improving. This is the engineering cycle. And this is the way that we help create a more innovative society. We don't give the answers, we don't give a plan. We start with a raw material, and everyone comes up with a different result. And then we test that result, and then we work out and discuss which one went furthest and why it went furthest. And we can actually then decide on what the best solution for the problem was. Yeah? And this is engineering. This is what we do as engineers. We build, we test, we improve. It's a cycle of continual improvement. Yeah? We can talk about different gear systems with this kit. So this is a planetary gear system. Okay, used in a number of different applications. An electric screwdriver is one of them, or an electric drill, that gear system. We can also build and talk and discuss ratchet gear system. So this is a ratchet gear. Okay. We also have things like cams and followers. So cams and followers used widely in engines, for instance. Yeah. So these are real engineering parts and real engineering processes. Okay.